All right, we're continuing RTI for Unit 4 test with number 8. It says Sir Isaac Newton was born on December 25th, 1642, and died on March 20th, 1727. Even though most people know him for his laws of motion, he was also a mathematician, astronomer, natural philosopher, alchemist, and theologian. Newton built the first practical reflecting telescope. Until this time, telescopes were based off of Galileo's refracting telescopes. He also experimented with light, developed the idea that white light is formed by the combination of the colors of light in the visible spectrum. In mathematics, Newton helped develop the mathematical ideas of differential and integral calculus. Which of the following was Newton not credited with discovering? Okay. Calculus, he developed the ideas of differential and integral calculus, so that's something he's credited for. Refracting telescope. Newton built the first practical reflecting telescope. Until this time, telescopes were based off of Galileo's refracting telescope. So, the refracting telescope was something that Galileo had put together, not Newton. Newton's telescope was a reflecting telescope using a mirror. Formation of white light. He experimented with light, developing the idea that white light is formed by the combination of the colors of light. So, formation of white light, that's something else he's credited with discovering. And of course, his laws of motion, Newton's first law, second law, and third law, are things he's well known for. So, number 8, the choice that you need to go with is G, refracting telescope, because the refracting telescope was something developed by Galileo. Number 9, during a tug-of-war competition, neither team is able to gain an advantage. Which of the following explains the forces in this situation? Well, if neither team is able to gain an advantage, that sounds like forces are balanced and that nobody is getting the best of the other team. So we're going to look for something that indicates that the forces are balanced, and that should be answer A. Problem number 10 is one that a lot of people missed. The first thing that you need to understand is that for every action, there's an equal and opposite reaction. For every force, there's an equal and opposite force. That's a statement of Newton's third law. So if this is the rifle and this is the bullet, the force that the bullet exerts back on the rifle and the force that the rifle exerts to push the bullet out, those forces are equal and opposite. So already, if I'm going to identify the action and reaction forces, I know I have to have two forces that are the same amount. I can eliminate F because those are not equal forces. I can eliminate G because, number 1, they're not equal, and number 2, they're not forces. They're in kilograms, and that would be mass. So I'm down to H and J. So I look at the numbers that I've got. I have a 7 kilogram gun, a 0.01 kilogram bullet, and a 7,000 meter per second squared acceleration of the bullet. I know from Newton's second law that acceleration is force divided by mass, or if the equation is rearranged another way, force equals mass times acceleration. So if I take the mass of the bullet, 0.01, and multiply it by the acceleration of the bullet, 0.01 times 7,000. Well, when you multiply by 1/100th, it's just like moving the decimal twice. So you wind up with an answer, a force of 70. And if there's a force of 70 on the bullet, then there's also a force of 70 on the gun. So your answer should be J, 70 newtons and 70 newtons. Okay, number 11. Velocity, remember, is a vector quantity, so it has to have both a magnitude and direction. Velocity measures both speed and direction. That's answer choice B. Number 12. Which of Newton's laws describe the relationship between force, mass, and acceleration as follows? Acceleration increases when force increases, but acceleration decreases when mass increases. In an equation, that would be acceleration is force divided by mass, and that is G. Newton's second law. Number 13, mass is measured in kilograms, while force and weight are both measured in newtons. So your answer should be D. Number 14, the illustration provided shows two boys pulling on opposite ends of a rope with different amounts of force. You have this one pulling to the left with 40 newtons, this one pulling to the right with 50 newtons. The net force is going to be the difference between the two because they're in opposite directions. So 50 minus 40 gives you 10, and it's going to be to the right because the larger force is pointing to the right. So your answer should be G, 10 newtons to the right. Number 15, for an object to remain at rest, which of the following must be true? For an object to remain at rest, all of the forces on it must be balanced. Okay? An object can have gravity acting on it when it's at rest. There can be friction present if the object tries to move, and the object obviously will have mass. So the only thing that even really makes sense on that one is A.